Yep, there we are. All right, so you can see me, and I still see the chat. So as we're going through this, as always, I'll pull the chat up from time to time, so that way I can address any questions you guys have. All right. So problem number one. Here we go. As we work through this, now I will have the ability essentially to write on the screen, but I purposely made it this way so that way I can kind of click through, make it easier, and the intention is honestly so we can cover more problems. So here we go. Okay, and as I mentioned, drop things inside of the chat. But my intention for today is to kind of re-articulate or re-describe to you how to think about the SAT and what to do when interpreting specific types of problems. Okay, so problem number one says the table above shows some values of x and their corresponding values of y, which the following equation shows a possible relationship between x and y. One thing I notice is that whenever I'm given a table here, and given the fact that I'm in the non-calculator section, okay, what you can do is sort of go immediately after where the x equals 0. And if you tackle this part here, right, then you can kind of plug these values in. And if you go and if you plug these values in, then where, say, for instance, x equals 0, then you should know that y is going to equal 2. So it looks as though A is going to be your best answer. The other way to do this is essentially we can figure out the difference here. We can kind of figure out the slope, because it says what is the possible relationship between x and y. And for this possible relationship, if I figure out the differences, right, between these, so I'm trying to figure out the relationship, which basically is synonymous for slope when it comes to the SAT. And as I'm referring to the change of x and y, I want to solve for the pattern, right, or I want to plug in. My pattern here is I have +1, +1, +1 as I'm going through. And then my pattern here on the bottom is +1, +1, +1. So my rise over my run is going to be +1, +1, right? So this is going to be my slope. Now, for here, which means this is a +1, then I would be down to A and B, and then I would probably end up plugging in anyway for my x equals 0, which is going to be, right, y equals 2. So A is still continuously going to be my best answer. Now, in a nutshell, whenever you have a table here, and it's asking you to derive or how they match up to the equations, most of the time it's actually really efficient to just be prepared to plug in. That's most of the time that's going to be your best course of action as you go through these. And the same applies for certain like linear types of problems. Okay, all right, so let's keep going. So here it says in the figure shown, line J is parallel to line K and line L is parallel to line M. Well, the words parallel in terms of geometry on the SAT, they're trying to kind of summarize to do various proofs. And I know that I've talked about this regarding our angles and lines section. I know that Mr. Brett has also talked about this. And what you want to be able to do is first locate what it is that you're trying to find, right? So first locate what it is that you're essentially going to need to do. And as I'm locating what it is that I'm looking for, I notice that it wants me to figure out what x is here. So then what I'm going to do is understand, well, the parallel lines, right, geometry rules, I want to pay attention to vertical angles, I want to pay attention to alternate interior and alternate exterior angles, and then I want to pay attention to supplementary and complementary angles. Remember, supplementary is when they equal to 180, being the full line. Complementary is when they equal to 90. Most of the time, when you're doing angles and line problems, they refer to supplementary. And they refer to supplementary because you see a line. They don't necessarily want you to derive if it is a 90-degree angle, okay? So focus on the supplementary instead. As I do this, I notice here, if this is 80 degrees, then therefore this vertical angle is going to be 80 degrees. If this is a line, right, or if this is a line, right, so here's my other vertical angle being 40 degrees. Well, now I can technically figure out what this angle is going to be, which is going to be 60, because 80 and 40, right, is 120, and then 180 overall. So this missing angle here is going to be 60 as I go through this. And then now I have this line, and as you can tell, right, given the fact that these are parallel, well, this here is probably going to be 60, right, given my kind of corresponding angles. This here, right, in terms of these being parallel lines and alternate interior and such. So I basically can kind of do the whole thing again, right, and I can figure this out. This is 60 for vertical. This is 60. That means that as this angle here and this angle here right? So this one's going to be 40, right? As I come down, and this one's going to be 80. It's kind of the same pattern of what you'll notice in terms of the lines being parallel together. So number 2 is going to be A, right? As I go through this. Big takeaway for this problem is whenever they give you the word parallel, and if it's an angles line problem, you really want to pay attention to vertical angles, alternate interior, which is where you have your 2 parallel lines here, and you have your transversal that cuts the 2 parallel lines. And this would be kind of your alternate interior. It's like when you do your Z within. That's usually how I envision alternate interior anyway. Okay. Let's keep going. Problem 3, the function f is defined by f of x equals x squared minus 5x plus 6. What is the value of f of 4? Well, whenever I have something that looks like this is just simply a functions and substitution problem. As we're solving f of 4, right, functions and inputs is the overall idea. We're going to plug in x equals 4. We get f of x equals x squared minus 5x plus 6. We plug in. We get f of 4 equals 4 squared minus 5 times 4 plus 6. This will become 16, right? Remember order of operations. This is minus 20, and this is 6. So this then becomes 16 minus 20 plus 6. And when I simplify this, I do 16 minus 20, which will end up giving me negative 4. And then I do negative 4 plus positive 6, which ends up giving me 2. 2 will be my answer, therefore, for problem number 3. Awesome. Okay, so here I notice one quick tip, right? And I hope the interpreting the problems is just as important as anything else, okay? When I see a lot of narrative here, I kind of sometimes want to skim down to my answer choices. And my answer choices, I notice, have a mathematical symbol that generally kind of refer to something. And this is an inequality, okay? So whenever I see an inequality sign inside of the problem, then I want to pay attention to specific types of language that they use to describe it. And that language, a lot of times is going to be, let's say, like at least, or no more than, or greater than, or less than. So the moment that I see this inequality sign, I want to think about language inside of the problem that they are going to use to describe that problem. So I'm not kind of caught off guard, right? As I'm looking for it, it helps me to sort of stay focused. And this says, a Racely can spend up to a total of $20, which means that no more than $20. And if they can spend no more than $20, then I'm attempting to not only match my rates with my variables, but I'm attempting to understand that the left side of the inequality here, the left side has to be less than or equal to $20. I cannot spend more than $20. So $20 has to be greater than the value of that side of the equation. Now, theoretically, if I'm breaking this down, immediately now I know that it can't be C or D because of that, because A and B are both less than 20. So now I'm just attempting to match my variables with the rates, right, for what these refer to. Streamers cost $1.49 per pack, and balloons cost $4.39 per pack. Which of the following inequalities represents this situation where S is the number of packs of streamers erasably combined, B is the number of packs of balloons? I simply just want to match these up. I just want to match, it's 149 S, and it's going to be 439 B. It does say where S is the number of packs and erasably balloon can buy. It wants to know total, right? It says, and this is your other hand. It says end balloons. It says erasably can spend up to total $20 on streamers and balloons. That and is a plus. Right, so that's essentially a plus sign as I'm going. Remember, up to is referring to $20 regarding your inequality sign. That's the big thing as you're interpreting the problem. The word and is referring to the fact that it's going to be a plus sign or the summation of both of those things together. I'm lining up my rate for $1.49 per streamer, and I'm doing my rate for $4.39 per balloon. And remember, as we break this down, the units would actually end up canceling. And it needs to be less than, sorry about that. And remember, it needs to be less than or equal to the $20, which essentially is what makes B our best answer, okay? All right, I'm gonna pause real fast before we keep going. I'm gonna look at the chat. Remember, we've only covered a few, right, so far, and the questions are gonna get harder, right, as you remember. But the biggest thing about all of this, and I hope the one thing that you guys have have kind of come to under alert is the test is approachable, right? If you know what to do, like some of these tests, I do in like minutes, because I just know what to look for, right? And it's kind of like you want to be able to read the defense more than anything else. So if you know what to look for, it really assists you in your preparation as you are setting everything up. So I'll give you a perfect example. In this problem, just using my answer choices as a guide, it says D equals 1000, right? D equals D equals D equals. Sometimes this might mean a literal equation, but because of the fact that they're giving me a lot of narrative here, this is probably going to be some sort of linear rate of some sort. So you just need to be able, when you're interpreting the problem, it kind of will help to designate to you, this is how I think about the problem. Okay, so more than anything else, and I hope for participating in this class, this is the one thing that you kind of take out of, right? And it makes it easier for you. Okay, here, all right. Bill is planning to drive 1,000 miles to visit his family. This is a total, 1,000 miles. If he plans to drive 250 miles per day, that is a rate. Which of the following represents the remaining distance? This means what is the equation, right? In miles that Bill will have to drive to reach his family after driving for N days. N is connected to a rate, so pay attention to that. Now, because of the fact that I immediately can tell this is 250 miles per day, this is N days, you should be aware that these two things are going to be next to each other, right? The 250 will be next to the N. So I can kind of tell it's either going to be, right, the 250N, the 250N, or the 250N. It most likely will not be B, essentially, right? That's kind of what I'm telling you, because this is 1,000 miles and then times days. That wouldn't work, right? Miles times days. So there's one way to break down this problem. Now, 1,000 miles total, 250 miles per day, that's your rate, N days. The distance is then going to be, and now what, pay attention to this, the distance is 1,000 miles and then minus, and then it's 250 miles per day times days. So this is going to be 250 M, right, or just 250 M over D times N, because N is in units of D. Now, what would happen here is that my units would cancel, right, my days and my days. And then this 1,000 is essentially my starting amount, right? And now also notice this, and here's a quick tip, right? If I follow the units, because it's asking me for what is the total distance here, this is in miles. Now, here's a master tip I will give you. If whatever they're giving you, and referring to even like linear equations or equations in general, if what I'm giving you or what I'm asking you for is in miles, then the numerator of the things right across the equation will all match the same unit, right? So that means that this has to be in miles. If in the instance I was like ever getting stuck like between them. So if I'm matching my units, I start with 1,000, I'm going 250 miles per day, which is also why I'm deducting this. It's because it says Bill will have to drive, which of the following represents the remaining distance, right? Remaining being that he has driven this many miles per day, so he no longer has to drive those miles. So that's why I'm subtracting it. That's why I'm not adding it to it. If I was adding it, he would end up getting more than 1,000 miles. There's only 1,000 miles total, okay? Now, so your overall answer looks like, therefore it's gonna be D as I break this down. But like, as I said, in any of these types of questions, you wanna try to essentially match up the units. Understanding that the numerator of the rate, right, and then the individual unit that will all always have the same unit, and then what you're looking for will also have the same unit. So just follow the units, and then it generally makes it the easiest way to do this. Right, awesome. Which of the following is equivalent to the given expression? Well, without overthinking this, I see all of my answer choices have like x to the fifth, x to the second, right, x to the fourth, etc. And I see up top here, it just looks like really I'm just kind of simplifying. And I have x to the third plus x to the second minus x. Well, I want to simplify this. And that means that the one thing you want to pay attention to when you're simplifying like terms is that if this is a minus sign here, or the plus, and if I have to distribute the negative sign, I just have to make sure to change the signs within the parentheses, right? That's usually how they get you. But for the most part, these questions are fairly straightforward, right? X to the third plus x to the second minus x. I distribute the positive in this case, just making this x squared minus x, and then I get x to the third plus x squared minus x. Now, I just want to combine and simplify my like terms, knowing that it looks as though I have three different like terms here, right? I have an x to the third, I have an x to the second. These are not the same like term. And then I have an x, and then I have an x. These are like terms, and my x's will cancel. And when my x's cancel here, I will remain with x to the third and x to the second, which is going to be my answer choice, making C my best answer for question number 6. Okay, great. Let's keep going. So here I have a large table, right? And I have a number of different graphs. All right, so here's your SAT hack or tip for the day. Whenever you have a large table and you have a bunch of graphs, as such, one of the things you're going to want to do is generally start with your y-intercept. So go where x equals 0, because it says the table gives some values of x and corresponding values of f of x, meaning, once again, whenever they tell you f of x, you are thinking y. Okay, you're always thinking y. This is your y coordinate. For a polynomial function, which of one could be the graph of f in the xy plane, or y equals f of x. Well, could be the graph, meaning that I just need to locate specific points on the graph. Now, granted, I might zoom in, but I think you guys can see this image fairly clearly. But I'm intentionally going to start with 0 and 2. So I'm trying to locate what these things are for the graph intentionally. So when x equals 0, y is going to equal 2, and it will be, let's see here, let's graph some of the points. It will be here. All right, so when x equals 0, y will equal 2. Here we are. One quick tip I will tell you is that as we are doing this, right, this goes from 0 to 10, 0 to 10, 0 to 10, 0 to 10, and it looks as though there are 5 lines. That tells me my increments are in 2, and you want to pay attention to that so that way you don't make kind of like a careless mistake. Knowing your increments will help you not make a little mistake when you're actually interpreting the graphs. Now, A, B, and D, the line goes through each of those. It doesn't go through C. So that's why I removed C from our possible answer choices. If we continue, what you then want to do is do the extremes. You want to try to do -2, -2, and 2 and 30. I do notice, though, that 2 and that 30 is like not on the graph, right? So that's going to be hard to interpret. So I don't like the 30 point. So I probably will do 1 and 7 intentionally, because that way it's more legible. I'm not trying to like predict it. So I'm intentionally x equals -1, y equals 3, and then I'm probably going to do -2 and -2, and then maybe 1 and 7, right? And I'm going to go back and forth. So here I have, let's see, x equals -1, y equals 3. It would be x is -1, which would be back 1, and then y equals 3, which would be like up, but a little bit over. So here, well, this is 2, so it's got to be over this, and then it looks as though it's going to be D, right? D seems to be the closest here and here. That matches, right? Because that's the point that I'm looking for. And now, just to double check, I'm going to do 1 and 7. So 1 would be like here, remember, because these are all in increments of 2. 7 would be, here's 2, 4, 6. So it would be somewhere, yep, it looks as though D is going to be my best answer choice as I keep going through. Here we have problem number 8. Here I have x plus 2 over x plus 2 squared. Which of the following expressions is equivalent to the given expression where x equals or does not equal -2? Now, whenever you have a question that looks like this, what you kind of want to always figure out is, granted, you could do which of the following expressions, and you can plug in numbers if you want to, but your goal is always to figure out how these things are going to relate together. And I hope that if you actually see an exponent on the SAT, and if you see the same thing, one recommendation I would make to you is to understand that this is kind of going to just like square this out, right? Don't foil it, but when you square this out, what I mean is that you're going to see that this is going to be simplified. So if I have x plus 2 over x plus 2 times x plus 2, then just cancel. Now the x plus 2's will cancel, and I will get a 1 over x plus 2. So rather than plugging in a number of values and series of a series of values, it will make it a little bit easier just to simplify. So it is B, right? As I do this, problem 8 is going to be B when I simplify this. Awesome. Okay. Here we have which of the following is an equation of the line in the xy plane that contains points 1, 3, and 5, 5, 15. Now, master tip. I see equation of a line. I skim down on my answer choices. All of these are in linear form, which means I want to pay attention to y equals mx plus b. If these are in y equals mx plus b, and if they're giving you coordinates, okay, they're giving you a 1, 3, and they're giving you 5, 15. Whenever they're giving you coordinates, eventually what you were looking to do is solve for slope, okay? And the reason being is because your slope equation is y2 minus y1 over x2 minus x1. Where else will you have 4 coordinates, right? And that's the idea. So if you're getting 4 coordinates here, just pay attention to the fact that you're really trying to figure out the m, and that is what will differentiate here between the different types of slopes. Okay. Now, so I set this up, and answers indicate slope-intercept form. That's right. So slope here, and then I'm going to do 15 minus 3 because remember, these are my y's. So let's do this here. 15 is y2, 3 is y1, and then 5 is going to be x2, and 1 is going to be x1. I simplify this, I'm going to end up getting 12 over 4, right? Which will then simplify to become 3. If 3 is going to be my slope, I go back to my answers, and it appears as though it is going to be A. If you're unsure, what the next step what you would do, like let's assume that you have another answer choice with a 3 as a slope, that's when you plug in, and that is how you would differentiate. So if I plug in, let's say y equals 3, and then if I plug in 1 for x here like this, right, y equals 3 times 1, I should get 3, which is what I get, right? So then this does work, and then that makes A the best answer to this question. Okay. Exactly. All right, so here we are. We have 4x plus b over 2 equals 2x plus 8. Quick tip, I haven't even read the problem yet, but I can kind of almost predict that whenever they're giving me multiple variables, they're going to ask for some sort of when the equation is not equal or when it's always equal, all right? In the given equation, b is a constant. If the equation has infinitely many solutions, exactly, what is the value of b? Whenever you have infinitely many solutions, okay, in the given equation, b is a constant. If the equation has infinitely many solutions, what is the value of b? Your goal is to attempt to get both sides equal, so that way you are only evaluating, actually, I'll be even more clear. Your goal is to get the x's to be equal in this case, because then you will only have an individual value left for the b in this instance. It could be like t, it could be k, it could be s. They love to use kind of the same variables over and over again. But your goal in order to make these infinitely many solutions is to get the x's to be equal. Now, they do you a favor because if I have a 2 here and if I cross multiply, right, if I take this 2 and if I cross multiply, it becomes 2 times 2x plus 8. And if I do 4x plus b equals 2 times 2x plus 8, remember to distribute. So 2 times 2x, and then plus 8. Well, 2 times 2x is 4x, and then 2 times 8, when I distribute, is 16. So now I have 4x plus b equals 4x plus 16. Now, this is what I mean. My sides are now equivalent, right? So as long as I continue to match up my b's with the other values, then therefore, right, this will consistently be infinitely many solutions. So as long as I make the 4 equals 4x equivalent, then the other values can equal the remaining values. And if that's the case, b will equal 16, making these solutions here to be infinitely many solutions, okay? If you wanted it to be not possible, I think there is an example problem actually in this test that does that, then you would do the same method and then you would find a way to make the other things not equal. That's the idea. It depends on the wording or the style of the question. All right, great. Let's keep going. What is the area in square units of the figure shown below? Whenever you have your, let's do a pen color that makes it a little bit easier to see all the time, depending on what the slide is. Okay, great. All right, for problem 11, area, right, perimeter, volume, all those things, always check your reference section first. It says, what is the area in square units of the figure shown? if you indeed have figures and you're attempting to kind of slice up those figures, what you want to focus on is usually triangles. Okay. They love triangles because of the fact that it's most of the time it's usually prevalent. Most of the time is what is in the reference section, right? You'll notice even in the reference section they have multiple diagrams of triangles, whereas they have a few others, for maybe like one thing for a cylinder, right? So when I look down at this problem, it says what is the area in square units of the figure shown? What they're trying to tell you here with these 90-degree angles is that if I were to draw like a little box here, then these would also be 90-degree angles, therefore making this a square. And if this is a square, right, then this is a 4, and this is a 4. Now, if this is a 4, right, given this section here, then that tells you that this is going to be a 3. And I mean, hopefully you can already tell, right, because this is 7, this is a 3, but they actually stay true to it. This is a 3, 4, 5 triangle, right? A 3, 4, 5 kind of special right triangle. Now, as I do this, that is where I draw my imaginary line. And here's my 4, right? Here's my 4, here's my 3, exactly. Now, as I'm figuring out my area of the square, that one's fairly simple. I'm doing, right, area equals length times width, which is area equals 4 times 4 is 16. Now I want to figure out my area of a triangle, which is my area equals half of base times height. And my base in this instance is going to be the 3, and my height is going to be the 4, right? Here's my height, 4, here's my base being the 3. I get half of 3 times 4, which is 12. So half of 12 is 6, right? So a equals 6. And then remember though, I have to add these together, right? That's the goal. I have to add what is the area in square units of the figure, right? So both of these. So when I add these together, for the total area of the figure, I'm going to get A equals 16 plus 6, which just gives me 22, making B my best answer. Okay, awesome. All right, what is the y-intercept of the graph of the y equals 4 to the power of x in the xy plane? Super, super important to understand. Whenever you see, and not to overthink this, whenever you see something where it says a y-intercept, okay, y-intercept is always going to referring to when x equals 0. An x-intercept, right, is where the y will equal 0. So be prepared for that as well in terms of the terminology. A y-intercept is where x will equal 0. So because of that, I'm just going to plug in x equals 0. And if I plug in x equals 0, first of all, you should be able to tell immediately, right, based off of your answer choices, that C is the only one where x equals 0. So this is like, you can do this question in seconds if you actually understand kind of the terminology and what it's asking, what it's asking you to do. But in general, what you want to be prepared to do, what is the y-intercept of the graph where y equals 4 to the power of x in the xy plane? You simply plug this in. Anything to the power of 0 is going to be 1. So y is going to equal 1. That does work, making C our best answer. All right, let's see here. Problem 13. What is the sum of the solutions to the given equation? Whenever I see the word sum, and whenever I see an x squared, what I am thinking about is actually quadratics, okay? And the reason I say that is because a quadratic form intentionally usually factors, right, if you remember this, and then the factors will have roots, and those roots are going to be the solutions. And it says here sum of solutions, which means that given the fact that you have an x squared, you may have to factor, you may have to solve for the solutions, and then you're going to add those solutions together, right, in some way. So let's prepare to get this in quadratic form. X squared minus 14x plus 40 equals 2x plus 1. I'm going to subtract the 1 over. I get 40 minus 1, which is what gives me 39. I'm going to subtract the 2x over, right, which is what gives me x squared minus 16x, because it's minus 14x minus 16x. And then this is going to be a positive 39. Now remember, whenever you're factoring, you want to figure out what two values here, when multiplied, like your last, right, will equal your last term, and then when added will equal your middle term. Also, as a quick tip, whatever the term is here, okay, this guy, whatever this term is, and whatever this term is here, that is the term all right? Or that is the variable that you will put here, okay? Because it's x times x, so x times x gives you x squared. All right, good. Now, so which two values when multiplied together will give you 39, but when added together will give you negative 16? Hopefully 3 and 13 seem to be the most logical choice. Negative 3 times negative 13 will give me a positive 39. Added together, they'll give me a negative 16. So as I'm factoring here, and here we are. But remember, I'm solving for the solutions, which means I have to set both of these equal to 0. And when I set both of these here equal to 0, I'm now going to do x equals positive 3, right? And then x equals positive 13. And I want to know what is the sum. So I have to add these together, right? So 3 plus 13 equals 16, making D the answer to my question, all right? Just in general, if you see something in a quadratic form like this, sorry, if you see something in a quadratic form, okay? If you see something in a quadratic form and it says sum of the solutions, be prepared that most likely you will need to do quadratic, and be prepared eventually that you're trying to figure out what the solutions are within the roots, within the factors, right? So sort of think about it in that step process, and it makes it a lot less intimidating for you. Also, huge master tip, if you ever see something with answer choices where you have this inside of your answer choices, okay? This is an immediate red flag. You'll be using the quadratic formula. You will not use it that often, right? And on the actual SAT, but this is the only time where if you see this, it is an automatic, okay? It is an automatic quadratic formula on the SAT, just to help you out, okay? Awesome, guys, sweet. Hope this is helping. Problem number 14, an equation up top, okay? Whenever I see this equation, that is a quick indication that I might have a literal equations problem. Literal equations, once again, is when here I'm solving for the value. So v equals v equals v equals v equals. It is a literal equations problem. So let's pretend I don't even understand what any of this is. I honestly don't even need to really read it. I can. Sometimes I do if it's in combination with another problem, but in this instance, I'm not. I'm not even going to read it because I know what the question is asking me to do. It's asking me to take this equation here and solve for v, okay? Now to be fair, in this instance, it doesn't look that great because v is in a fraction and an exponent under a radical, okay? So they sort of like threw everything at you mathematically. So what your goal is here is to get v by itself first. So you have to kind of order of operations wise, you have to break it down a little bit. So let's do that. Which line gives the speed of the object in terms of the quantities? That's what v is referring to. Here's your literal equation. L equals s radical 1 minus v squared over c squared. If I divide both sides by s, then I get L over s equals radical 1 minus v squared over c squared. Then what I'm going to end up doing here is because of the facts, actually, I would always intentionally use my answer choices as a guide, meaning that if I have L over S now, I would actually want L over S in my answer choices. That doesn't help me at all because all of these are L over S, okay? But now the way that I get rid of my radical is I have to square root both sides, right? So I basically would do this I didn't show the step all the way, but I would do this, okay? I would take a square root and then I would take a square root here, right? So that's where the L over S squared equals 1 minus v squared over c squared. Then this here, L over S squared becomes L squared over S squared. And then this equals 1 minus v squared over c squared. And now, because of the fact that I'm trying to find v squared by itself, I want to get rid of this 1 first, okay? I'm going to bring this 1 over to the other side. And let me slide out of the way a little bit. When I bring the 1 over to the other side, I get L squared over S squared minus 1 equals negative v squared over c squared. Now, let's be fair. I don't really like the negative because these are all positive v's. So I'm going to have to do something about the negative. I can either do it now or I can do it like towards the end. I'm probably going to do it now because it's easier to do it now. Just multiply the entire thing by a negative 1. And if I can multiply the entire thing by a negative 1, then I end up getting negative L squared over S squared plus 1, right? Because I do -1 times this, then -1 times the -1, which is what gives me a +1, and then -1 times the v squared over the c squared. That is what gives me a positive v squared over c squared, with my entire intention being to get this in eventually a positive form, because that's what I'm trying to solve for. Okay, good. Then I'm going to cross multiply for what you can see. Now, you may have also noticed that this is still in negative form, right? This is a negative L squared over S squared plus 1. But what I actually would do on test day, and not to make it like super complicated, is I would intentionally check back to my answers. I would use my answers as a guide, and my answers all are 1 something, right? You guys notice that? So it's like 1 minus 1 plus 1 minus 1 plus. So what I would then end up doing is I would just rearrange this. I would rearrange it according to what I see here. And I know it's going to be 1 minus L squared over S squared. And the reason I'm doing that is so I can get rid of the things that no longer work. I'm getting rid of the plus sign here, right? And now I'm down to A and C, right, as I keep going. And I cross multiplied my c squared. I bring this over here. And now, finally, in order for me to get v squared by itself, what I end up having to do is do the entire thing here, right? V squared, or radical, right? Take the radical here, take the radical here, and yep, they do. They bring the c out. So they bring the c out, so that way it just becomes c, and then it finally is negative L squared over S squared plus 1. Right, so the c here is because it was a radical c squared, which then became just a regular c, and this should be my answer choice. But I purposely rearranged it, as I said, to make it easier for me. So it looks like A is going to be my answer, right? As I rearrange this, A is going to be the best answer to my question, right? If I just do the 1 in the front, so it becomes 1 minus L squared over S squared. Awesome. Great, guys. All right, so here we have let's see here, the half-life of a certain substance in the aquatic environment is about 150 years. I'm going to pause reading real fast. I'm going to use my answer choices as a guide. What I can immediately tell is that these are all like a y equals something, but here's the difference. These all have an exponent that's attached to it. So really what this question is asking you to do is interpret exponential models. Okay, that's what this question is asking you to do. All right, so I'm just lining that up in terms of things I pay attention to when I'm doing exponential models. Which of the following exponential functions best models the amount in grams of the substance t years after 200 grams of the substance is applied to the aquatic environment? The half-life is the length of the time needed for an amount of substance to decrease to 1/2. Well, they're giving you this for a reason, because it's kind of a definition or a condition. Hopefully you guys know what half-life is, or you've heard of it in some capacity. Most of the time you learn about it in like radioactive decay within chemistry. And it says, which of the following exponential functions best models? Now, what you want to do whenever you have questions like this, okay, first identify what the condition is. In this instance, the half-life is 150 years. Then what you want to do is you want to identify what the value would be, okay? This is huge, all right? So pay attention to this. You want to understand, okay, if t equals, let's say, 150, right? In this instance, where I'm plugging in values, right? I'm basically going to test values. If t equals 150, then you should understand, as I'm testing values, that a of t, in this instance, or really y, right, is going to be 100, because that's half of 200. So it's going from 200 to 100. And now I'm going to test values as I plug them in here, and keep it easy, right? Keep it easy, because you're in the non-calculator section, right? You don't actually, you're not going to have the ability to really test like hard exponents, because you're not going to have your calculator on you. So you want to really simplify this for you. Now, you can probably already tell that it looks like it's probably going to be D, right? But I'm gonna let you in on a few other ways to kind of interpret this problem. The other thing you want to pay attention to is, as you're plugging in, you might need to test more than once. So let's pretend you do t equals 300. Let's pretend you go through 2 half-lives and not necessarily 1 half-life. Then in that case, Well, you're just going to divide the 100 again by 2 because it's half. So then this is going to be 50. So at t equals 50, we should get a of t equals 100. Or at t of 300, we should get a of t equals 50. And that's what you want to pay attention to as you're plugging in these values to kind of test them, okay? We're going to test our numbers, right? After t equals 150, a of t equals 100. I'm now going to plug it into my equations. Let me pause for a quick moment. The reason why, and you might be able to kind of tell this already, the reason why I chose the 200 here, okay, and then I told you this before, is that if you follow the units, okay, here, this is in units of grams. Well, this is the numerator, right? Which means that this here also has to be in units of grams because of my numerator. And the t is time. That's referring to 150 years. So that's why this is in years. That's why it's connected to there. So just being an understanding the process of units and how units cancel, and really kind of more like fractions more than anything else, or dimensional analysis, is that's going to help you out tremendously. So the 200 is what goes here, not the 150. And even if that's all you know, you're immediately gone with A and B, right? Because you know that if A of t has to be in grams, right, then you know that this here, which is technically always referred to as your initial amount, right, that also has to be in grams, and that will save you some time. So that's why I'm intentionally testing C and D, right, regarding my half-life. Now, if I plug in t equals 150 here, you can obviously tell that this is going to be A of t equals 200 times 1/2 times 150 over 150. This would then be 1, right? 150 over 150 becomes 1. And then it just becomes 1/2 to the first power, which is 1/2. 200 times 1/2 will give you 100, and that is what I had predicted. And this is the only one that will work for that, right? You could test the other ones if you'd like to, and I encourage you to do so you can kind of see the idea of kind of how everything works out. But D is going to be your best answer then in that regard. Awesome. All right, problem 16, open-ended. Now, remember, and we talked about this before, right? And we're 11:23, okay? So I'm going to go a little bit faster so we can get to most of section 4 as well. And like I said, I'll intend to stay on for just a few more minutes, so that way we can get, go through as much as we can, all right? The graph of y equals mx plus b, where m and b are constants, is shown in the xy plane. What is the value of m? Remember, whenever they're giving you this line here, this line is straight, that's a y equals mx plus b. Pay attention to the fact that whenever you have open-ended problems, they must be positive. There's no radians or pi in your answer, and there's no radicals within your answer. Remember, you can't bubble those in. So that should help to kind of guide you a little bit. Your y equals mx plus b being your linear line, and they're giving you the graph. Whenever they're giving you the graph, they're expecting you to do rise over run to solve for the slope. That's usually the fastest way. So when I do rise over run, I just want to pick out points that are very obvious, okay? And I'm going to go up to, it looks like I want to check my increments. That's a big thing. Check the increments to make it easier for you. I go up to over 1, right? It looks like I'm going here, and then I go up to, and then over 1. Yep, going from -1 to 0, -2. Yep. So I'm going to go up to and over 1 both times, meaning my rise over my run is going to be 2 over 1. My answer is 2. That is what I bubble in. My answer is positive. There's no radians. There's no radicals. Yeah. Awesome. All right. If the xy is a solution to the system of equations, what is the value of y? Now, you guys have asked me, and I know you've done problems that are similar to this. You've asked me a bunch of times, when you do, elimination versus, you guys ask me this a lot, when do I choose elimination versus when do I choose substitution? And I'll let you in on a little secret, okay? Whenever you see system of equations, that is when the x's equal the same thing in both equations. It's technically where they would like intersect, right? It's like the point on the graph where they would intersect if you were actually kind of drawing this out, okay? But what I'm going to come back to this. Here we go. Just so we have a clean. When I'm choosing between elimination or substitution, the one thing I generally pay attention to is the coefficients that are in front of the numbers. Now, if I have a easy coefficient, right, then I will generally do substitution majority of the time. if my coefficients are rather, difficult, then I'm almost like, let's say for instance, I have like 12x plus 4y equals 16 or something like that. Whenever I start having a bunch of coefficients, that is when I will generally do elimination. I'll find the common multiple between them, I'll add or subtract the equations, and then I'll solve for one variable or the other. In this instance, they only want me to solve for y, right? So you can do elimination anyway, but I'm intentionally going to use substitution because my coefficients here are pretty easy, right? So as I do this, systems of equations, x plus y equals 5, 2x equals 5, I'm going to, because of the fact that I want to solve for y, I'm going to take my bottom equation here, 2x equals 5, I'm going to solve for x. So I get x equals 5 over 2. I'm going to now plug this in over here, and I'm going to get 5 over 2 plus y equals 5. And I'm going to get y by itself. So I'm going to bring this over here, and I'm going to get y equals 5 minus 5 over 2. Remember, it's fractions, so I have to find my common denominator between these two. This is a 5 over 1. In order to make this a over 2, I have to make this a 10 over 2, which is then minus 5 over 2, which, yeah, actually becomes, right, 5 over 2. So so my answer is going to be 5 over 2. You can also plug in, if you were to solve this a slightly different way, it's going to be 2.5, right? If you do your decimal form, but they will accept either on a test day. Okay, so 5 over 2 is going to be your best answer for this. What positive value of x satisfies the equation above? Remember that for open-ended problems, it always has to be positive. This is, you understand that here you have factors. Okay, that's what these are. Okay, and what you're trying to do is you're trying to solve for the roots or the solutions. So what you want to do is you want to set each of these equal to 0, right? When you break this down, x minus 3 equals 0, x plus 1 equals 0, and then it would be 5 equals 0. You want to know what positive value, though, what positive value of x, which this would become x equals -1, yep, and x equals 3. So x equals 3 is going to be my answer because that's my positive value regarding these. If they did ask you to FOIL this out, then you would simply just multiply all of these together, right? And you would probably FOIL this first, the x times the x and the x times the 1, right, etc. And then you would multiply and essentially distribute the 5, okay? But whenever they have things lined up in factors, I would honestly say 9 to 10 times, whenever you have factors here, they're usually referring to graphing problems, or they're referring to solving for the solution, right? So your x minus 3 equals 0, x equals 3 is the answer to this question. What value of x satisfies the equations above? Okay, well, all right, 3x minus 0.6 equals 1.8. And now remember, you're in the non-calculator section, so if you have trouble with decimals, then that's understandable. And I'll show you guys some quick hacks to make that easier. What value of x? And I would just add the 0.6 over to the other side, and I get 2.4. So 3x equals 2.4. If you have trouble, right, I'm just dividing, right, by 3 on both sides, and I end up getting 0.8. Let's pretend you have trouble with decimals, though. Okay, let's pretend I'm gonna do this a little bit differently. You know that x, right, after I cancel these out, and I hope this helps you guys, right, for on test day, x equals, and then this is 2.4 over 3. Now remember, 2.4, or just even for that matter, like a 0.6 is really 6 out of 10. Okay, and a 1.8 is going to be 18 out of 10. Okay, so if you just think of these as putting them over 10, then it will make it a little bit easier for you if indeed you like fractions better, kind of. And so here is let's say 2.4. So I'm going to do 24, right, over 10. Okay, and then this is then divided by 3. So if you have more difficulty with decimals, but instead you prefer to use fractions, now remember, if I'm dividing by a fraction, it would look something like this: 24, right, divided by 10, and then this would be divided by 3. But if this is divided by 3, remember what you have to do. You have to flip this to become times, and you flip this to become a reciprocal. So it becomes 1/3. So this becomes 24, right, divided by 10, like this, times 1/3. And 24, right, times 1 would end up giving you, right, 24 like this, and then divided by 30, which you'll end up getting, right, when you simplify this enough, you'll end up getting 0.8. But the best way to do this, honestly, is to figure out if you can simplify anything, and you can, right? 24 divided by 10, this, right, 24 and 3, this goes into it 8 times, right? So 24 divided by 3 is 8. So this becomes 8 over 10, and you can simplify this further, right, if you want. If you divide both, right, by 2, and then this would end up giving, right, 4 over 5, which they would accept. So that this could be an answer choice. Or remember, if you convert it back to decimal form, 8 over 10 equals 0.8. So you can do it either way. Now, if you get intimidated by decimals and you might not remember all the rules to decimals, then I suggest trying to work in fractions, because they're far more applicable, certainly for the SAT, and definitely when it comes to the open-ended section. Okay. All right, let's see here. I see that I have a comment, so I'm gonna click on that real fast. It says, let's do this. Let's see here. I see another way you can do them is regular numbers and keep 1 digit after the decimal, since the numbers in the problem have 1 digit after the decimal. I'm good with that. Yeah. That's what I'm saying. If it depends on how you feel about decimals, okay? Like it depends on how you feel. I personally tend to convert everything to fractions, and here's the reason why. Because if you think in fractions, you can simplify, right? And I tend to refer to everything in fractions for the non-calculator section. Let me specify. If I'm in the calculator, I'm going to use my calculator as an advantage, right? It saves me time. But if in the non-calculator section, I'm looking to simplify first. That's the idea. I try to simplify first before I move on to the rest of the problem. So if I get stuck with like the 2.4 over 3, and if I'm like, maybe, only because of the fact that it's open-ended and there's no other answer choices to guide me, I probably would end up just converting it to a fraction, simplifying it, and then saying, oh, yep, it definitely is 0.8, right? Just to make sure that I'm absolutely right and I don't miss like a little question, okay? Now a calculator, right, 24 over 10, 24 divided by, you flip this for the reciprocal, and you end up getting 8 over 10. Awesome. A square is inscribed in a circle with radius 6 radical 2 inches. What is the perimeter of the square in inches? Now, we've done this problem in the past, but remember, whenever they give you radius and whenever we're talking about circles, you want to remember like area of a circle, circumference, arc length equations. You want to remember those things. Those are the big things. However, here's the flip side. Whenever they start telling you that you have like figures, okay, whenever they start doing figures of some sort, one thing you want to pay attention to is that they love them some triangles. Okay, so here's our, so that's what I mean, and that's what I'm referring to. Square is inscribed in a circle. Here's your square, 4 equal sides. They do say what is the perimeter of the square, so you want to pay attention to that. The radius of the circle is 6 radical 2 inches, which means that from a midpoint sort of to an outside point of the circle. So like, let's pretend I'm here, and if I go out here, right, that's a radius to the circle. However, that doesn't help me at all in this problem, drawing that type of line. And here's the reason why. Because you need to figure out how to relate the square to the circle. The best way to do that is by focusing on the diagonal instead, by focusing on the point where they meet, right, literally. So when I do this, and I understand the radius is going to connect the center of the circle to like an endpoint, then I'm trying to understand, okay, well, my diameter of the circle is going to be the diagonal of the square that I can see. And if I have 2 diagonals kind of slicing this, well, now I have triangles, right? And if I have triangles, now I can start to think to myself, oh, well, maybe I have a special right triangle, maybe I have 90 degrees, maybe I have something along like Pythagorean theorem, and most of the time you will. If I cut this exactly into 4 pieces, you might remember that the square, right, I'm sorry, the circle is 360 degrees. So hopefully you remember that if I'm cutting this into 4 pieces, each one of these are actually going to be 90 degrees, okay? This is 90 degrees, 90 degrees, 90 degrees, 90 degrees, because the full circle is going to be 360 degrees. Now, if these are 90 degrees, I do have special right triangles. And if I have special right triangles, and if I know that these are my radii, right, 6 radical 2, 6 radical 2, notice it's going from my center to my endpoint, right? And, well, hold on, let's back up a step. I see here that I do have special right triangles. I see that this technically, let me do this. This is technically isosceles, okay? So what I technically have is a triangle here, or these angles equal. This is like a 45, right, and a 45. And this is technically my 90-degree angle. So you could recall, and you can use your reference section kind of as a reference, but this is x radical 2 because it's across from 90 degrees. This would be x, this would be x. These, in this case, are going to be your x. So it seems funky because it's like you're doing a 6 radical 2 and then with a radical 2. But it's because if this is 6 radical 2 being your x, and if I plug this in, then this is going to be 6 radical 2 times radical 2, right? And I'm like combining them. If you get stuck though, if for whatever reason you don't see that these are special right triangles, when you do the radical 2 times the radical 2, end up giving me 2, 6 times 2 gives me 12, 12, 12, 12, 12, will end up giving you 48. 48 is going to be your answer. Let's pretend you get stuck and you're like, I don't see that these are special right triangles for whatever reason. That's when you would use Pythagorean's theorem. And Pythagorean's theorem is your a squared plus b squared equals c squared, because of the fact that you have, right, you have 2 sides of a right triangle and you're trying to solve for the other side. The other side that you're trying to solve for in this instance is going to be c, which is going to be your hypotenuse, right? That's the side that is across from your 90-degree angle. So it's the side that's across from your 90 degrees. And then when I do this, I see that I end up getting 6 radical 2 squared plus 6 radical 2 squared equals c squared, right? And remember that if it's 6 radical 2, I have to do to both of these. So this becomes 6 times 6 is 36. Radical 2 times radical 2 is 2. So it becomes 36 times 2, which is what gives me 72. So, and then it's the same thing. So 72 plus 72 gives me 144. I get 144 equals c squared. I therefore will end up getting 12. So I can do it both ways, right? I either remember that this is a special right triangle, and that's essentially the fastest way, or I use Pythagorean's theorem because it is a right triangle, and I can use Pythagorean's theorem under those conditions where 12 equals c. I still end up getting 12, but I'm not done. Remember, because always you don't want to make a little mistake. You want to remember that it says what is the perimeter of the square. So this is 12, 12, 12, 12. And what I want to do is I want to do my 12 times my 4, right? As I set this up. And right, 12, 12, 12, 12 equals 48. 48 is going to be the answer to this question. All right, it's positive. There's no radians. There's no radicals within. My answer choice is possible, right, as I do this. Awesome. Okay, guys. All right, let's see. So let's move into section 4, right? Let's try to do as many of these as we can. And because that took a little bit of time, right, as we do this. And I hope, actually, you know what I'm going to do? I'm going to choose certain problems, okay? And I'm going to try to kind of recap like the essentials of things that you guys should pay attention to, because I know that we're down to like our last 20 minutes or so. All right, so let me end this, and I'm going to go to certain problems to make it easier for you as you do this. All right, first type of problem that I'm going to quickly recap is whenever you have a large table, okay, like for problem 3 here, it says American marsupials and Australian marsupials are 2 primary groups of marsupials. The table above shows the number of species in each of the order of living marsupials by group. I go down, it says based on the table, what fraction of the Australian marsupials are of the order of Paramelomorphia. Now, same applies when you have probability problems, proportion problems, ratio problems, in this case, fraction problems, right? They kind of all go the same idea, essentially, when you're trying to solve the with a large table. But what you want to do first is start with the denominator, Okay, so as you're doing this, and as you're attempting to start with your denominator, it says what fraction of the Australian marsupial species? That's your denominator. That's of the more Australian marsupial species. So this is these species here: the 1, the 71, the 24, the 2, the 137. These are all included within the Australian marsupial species. And then you want to figure out, according to this question, are from the order of this. So this is the order of the para of marsupial species. Now, when I do this, I'm going to add these up because I'm in the calculator section. I'm going to save some time. I don't even care about the American in this instance. And the fraction is 24 over 1 plus 71 plus 24 plus 2 plus 137. I add them together. I get 24 over 235. I notice that it's not going to be simplified. And if I look at my possible answer choices, that seems to be the right answer. So B is going to be my right answer for this question. Okay, good. For this type of question, whenever I see problem 4, right, and here I have a graph, it says 10 data points are in the scatter plot shown below along the line of best fit. Line of best fit, whenever you see something that's straight, that's a quick y equals mx plus b. It says which of the following best estimates the predicted value of y when x equals 6.5. Now, best estimates means that it may not be shown on the graph, and you're trying to predict it based upon the line of best fit. Also, quick tip: you want to pay attention to the increments, and you want to pay attention to if there is a 0 present, like if there is an x equals 0 or a y equals 0. If not, most of the time you'll end up plugging in, right, when you do that type of problem. So 10 data points are in scatter plot, and then I simply just want to locate where x equals 6.5. So it's gonna be like right around here, and then I plug that in, and I'm just trying to figure out what the y is. So it seems as though it's going to be 16, right? From my answer choice, and 16 is a possible answer, so I'm done, right? Problem number 4 is going to be D. Okay. Things to consider when you look at this type of problem, though: look at the increments, understand line of best fit generally refers to slope. You see that it's a straight line, so it's a y equals mx plus b if you need to pick points. Also, if you need to somehow figure out the slope, like for whatever reason, pick data points that are the closest to actual data points, okay? Let's end this real fast. I'm gonna continue to find problems that are a little bit kind of reviewing things that we've done to kind of help you guys. All right, for percentages problems, something like this. For problem 12, it says the table above shows the distribution of the number of extracurricular activities that students at a middle school participate in. If the number of students who participate in 2 extracurricular activities is 120 more than the number of students who participate in 1 extracurricular activity, what is the total number of students who attend the school? So they want to know what the total number of students is. I understand, and remember, nothing is really random. They always intentionally give you things so that way you have enough information to solve the problem. That's the purpose of it, right? Everything is a tool on the SAT. And what they're asking you here, or what they're giving you, this anecdote: if the number of students who participate in 2 extracurricular activities is 120 more than the number of students who participate in 1 extracurricular activity. Now, that is telling you that the difference between them equals 120 students. Well, if I can figure out what the difference is here, which is fairly straightforward, actually, it's like 55 and 30, then I can figure out that that difference is going to equal my 120 students. Well, the number of students in 1 activity is 30%. The number of students in 2 activities or more is 55%. I take the difference, and that's going to end up giving me 25%. That 25% is going to be equivalent to 120 students, which is 1/4. Now, you could set up the full ratio if you want to, but in this case, because of the fact that I know that if it's equal to 1/4, right? Let's pretend, I guess what I'm saying is that you could do, okay, well, right here. You could do your 25%, right, is equal to 120 students. And then you want to figure out, okay, what is my X number of students for 100%? That's basically what I'm telling you, is that, okay, well, how 25 goes to 100 when you multiply by 4 times, therefore 120 times 4 is what is going to give you your total number of students. That's where I'm getting 480 from, okay? Right, so that's the best way to do that problem as we work through it. Right, so here we have, let's pick some other ones out, all right, as we do this. Here is another problem where it says in the xy plane, what is the y coordinate of the y-intercept? Once again, let's not overthink this. Y-intercept is when x equals 0, right? So when x equals 0, I'm going to plug that in. I get 3 times 0 minus 12 over 0 plus 2. I then get negative 12 over 2. I'm going to get negative 6 for my answer, and negative 6 it is, right? So, and this is my coordinate, which is x equals 0, y equals negative 6. And the reason I always give it to you in coordinate form is because they can easily just change the answer choices and say what point would most likely appear on the graph, or something to that extent, okay? So A is going to be my answer to this question. All right, here we have the coordinates of points A, B, and C are shown in the xy plane above. For which of the following inequalities will each of the points A, B, and C be contained in the solution region? Well, two different ways to do this problem again, because you could go old school, right? You could actually do the inequality because according to my answer choices, I have inequalities here. And if you do the inequality, right, for my linear equalities, I can attempt to graph this. And if I attempt to graph each, I would start with each one, right? And I have y is greater than negative x minus 2. I'm going to plot my intercept first. So where x equals 0, y is going to be negative 2. So I check my increments. This is to 4. This is to negative 4, 4, 4. I'm going to start here, right? That's where y negative 2 when x equals 0. And then I would do my negative 1 for my slope, right? So I would go down 1 over 1, down 1 over 1, down 1 over 1, and then we'll go back 1, back 1, back 1. Now, here's the interesting thing, is that this means greater than. And because of the fact that it's greater than, it means I'm going to shade above the line. And if I shade above the line, then all of my data points are actually going to be included, right? It covers all 3 of these data points, or all 3 of these quadrants. Let's pretend that more than one of these worked in that instance, though, because that is possible, right? You may not get it right on the very first one that you attempt to graph, and this could take some time. If you're literally graphing every one, or heaven forbid you shade the wrong way, right? And then it's up. The other way to do this is to kind of plug in, to test them. So if you plug these in, I guarantee you A is going to work, right? If you get stuck and maybe you're unsure of how to do linear inequalities, right? Then what I would also encourage you to do is to plug them in as you test these. So that way it makes it a little bit easier. Okay. All right, let's look at. I know you guys have definitely done the triangles problem in the past, so, and I believe even with me. So we're not going to do that one. I'm going to move on to some of the others. Matter of fact, because of the fact that we're kind of approaching the last, like, let's say I'll stay on for like an extra 5 or 6 minutes or so. If you have specific types of problems that you would like for me to cover, let me know as we're kind of approaching the last little bit here. Here is a perfect type of problem that I'm referring to, where for problem 20, where you notice when you're checking your increments and you're checking your labels on the graph, you do not have an x equals 0. There's no 0 here, right? So what you don't want to do is fall victim to the idea that when you're plugging these in, right, that you immediately are going to find your intercept so easily, because you're not. You're going to have to end up plugging this in. It says the set of data is represented by the scatter plot in the portion of the xy plane. Just find linear equations best fits the data. Okay, so best fits the data refers to the fact that I need to find, first, because all of these are linear, I want to find something where I do have something like with a y equals mx plus b. I'm basically trying to predict my line of best fit. Okay, that's what I'm attempting to do. I'm trying to predict my line of best fit, understanding that these are approximations as I go through. If I do approximations interpreting graphs and figures, right, line of best fit is going to refer to slope. I'm purposely picking points that, like, one is further up and one is down below. And it seems as though my wife is working out, so don't worry about that. Okay. So here we have 6.6 and we have 5.2. So what I'm going to do is I'm going to choose my x, and I'm going to choose my x values here and my y's. So slope equals 120 minus 95 and 6.6 minus 5.2. I'm choosing my x and my y values. I get 25 over 1.4. And now pay attention too, because we are in the calculator section, so you can use this. But remember, you're not going to get the exact value. Seldom will you get the exact same thing. I then end up getting 17.86. I notice this is positive because it's going upwards, which technically I could have saved some time and I could have done that as well. So it's probably going to be the 16x, right? It's going to be one of these two if I had to, basically if I had to kind of guess. It's not going to be in a decimal form, and it's going to be positive. So it's either going to be between C or D. Now, as I'm doing C or D, then what I want to use is I'm going to use 16 because that's the slope that they're actually giving you. So that way you can get the most accurate answer, okay? Here, I'm going to choose another data point, and I'm going to plug this into my y equals mx plus b. When I choose the data point, remember, I'm going to use 16 for my slope, and I get y equals mx plus b. I plug this in, so I get 95 equals 16 times 5.2 plus b. I then will end up multiplying these because I'm in the calculator section, and I get 95 equals 83.2 plus b. I would then subtract. I would get 95 minus 83.2, and that's going to give me 11.8 equals b. Now, this too is going to be positive, so I like my D the best, even though it's not perfect, right? That's okay. What I notice is that this is going to be positive, this is going to be positive, and they're not in decimal form. So that's most likely to be my most accurate answer, okay? All right. And let's go to, let's see here, let's pick a couple more. There are a few that could be really challenging, and I know we've had the pleasure of kind of covering majority of the problems. I wanted to do some more of the tables and graphs for you guys to make it easier. Let's pluck this one out. Okay. All right, so this one's a little tricky, and this is kind of similar to the one that we did previously, which is the equation. In the given equation, k is a constant. If the equation has no solution, what is the value of k? Now, what we talked about before is that whenever you have infinite solutions, your goal is to get the equations essentially set or equal on both sides. Well, it's likewise. If you have no solution, it's actually kind of the same strategy. What you want to try to do is get the x's to be equal on both sides, and then essentially attempt to get the k's so that way they won't be equal, right, on both sides. Because it says, what is the value of k if the equation has no solution? Well, if I distribute this, I end up getting my 1/3 x minus my 1/3 k equals kx. And remember, we're attempting to make the equation equal on both sides for x. So if I do this, now I can't really do any more unless I begin plugging in numbers, okay? Or unless I begin plugging in answer choices. And if I use my answer choices here as a guide, then what I could end up doing, right? Well, first of all, let me back up real fast. Understanding kind of the order of operations here, I can already see that this is going to be a minus, right? And this is multiply. So they're not going to be equal theoretically if I'm choosing 1/3, I believe. Like, yeah, if I have 1/3, 1/3, 1/3, right? These won't be equal. Because if this is a 1/3 x, right, and if this is a 1/3 x, notice what I did. I was able to get the 1/3 x on both sides theoretically, right, by doing this, but my k's will not equal because this would be multiplied and this would be a minus. So that won't work, right? So I can almost immediately tell that 1/3 is probably going to be my answer choice. Now, the other way to do this problem, and probably the way that I honestly would recommend, is to look at it this way, all right? Let me back up real fast and come back to this problem. So let's do this and this and this. All right, here's the other way that I would attempt to do this problem, just to make it easier for you, so that way it's fairly consistent regardless of the type of question you get, is that it says if the equation has no solution, what is the value of k? What I would attempt to do is that if you plug in k, right, if you plug in a value for k, you won't be able to solve for x. That's the idea, right? So if you plug in k, there will be no solution for x. So you can look at this kind of in reverse, right? No solution for x, okay? And if I take my values here, and I'll go back to my equation, 1/3 x minus 1/3 k, okay, equals kx, then if I take, and I'll do a -1, for example, which is not your answer, but I'm just plugging this in like first. Then I'm gonna plug this in for k, by the way. Then I get 1/3, okay, x minus 1/3, and this is gonna be times like 1, like this, equals, now remember, I'm plugging in a 1 here. This will give me 1x. Now, I can like add and subtract. What you're going to end up seeing, though, to make this easier, is you're going to be able to solve for x. And because of the fact that I can solve for x, that means that it's solution. So this value will not work for k, because I'm looking for an instance where when I do solve this, right, 1/3 x minus, that these things won't equal. So then this is x, right? I bring this x over here. Then if well, actually, let's subtract. What do we want to do? Let's see here. I'll subtract x and I'll add the 1/3 to the other side, right? So then I get my 1/3 x minus x equals a positive 1/3. I'm basically just switching sides. Now, because of the fact that these are both an x, I have to make this a common denominator. So this becomes 1/3 x, and then minus my 3/3x equals to 1/3. Already doing some other math, right? So here's my 1/3. This simplifies. I get -2/3 x, right, equals my 1/3. You can kind of already tell, right, that I'm going to be able to solve for x, right, if you get the idea. So I'm going to get 3/2. These cancel, right? And then I do times this, 3/2. Okay, so then I get 3/6, which gives me -1/2, which means because of the fact that I can solve for, right, this is a this is a -1/2, right? 1 times 3 is 3, 3 times -2 is -6. So because of the fact that I can solve for x, it means that this won't work, right? Now, here's the other way that I'm looking at this, okay? And I know this question seems a little confusing. That's why I'm spending time on it. And to be fair, everybody gets it wrong, okay? That's why I'm spending some time on this. Is because let's pretend I do the 1/3, which is the answer. Let's pretend I plug this in. 1/3 x minus 1/3 k, right? This is already, if I distribute that, it's the same thing as before, and this is kx. Now let's plug in 1/3 for k, right? K equals 1/3. If I do 1/3 x minus 1/3 times 1/3, right, for k, and now I'm going to plug this in here, 1/3 x. Well, look what I just did, right? Hopefully you could tell immediately, hey, I have a 1/3 x on this side, and I've a 1/3 x on this side, right? Now, this would be a 1/9, right? So 1/3 x, but no matter what I do, because these 1/3 x's are the same on the other side, they will end up canceling each other out. So there will be no solution, which is what makes this D your best answer, right, to this given equation. That's the idea. That's essentially what I'm trying to tell you, is that if you get stuck, right, where if the equation is no solution, what is the value of k? What you're really attempting to do is use the other values then to see if you can find other solutions. And if you can't, then you obviously know what your best answer choice is going to be. Okay. Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.